Hello everyone, and welcome to Serverless Days Student Edition, to this session where we're going to talk about function orchestration in the world of serverless. So what does that mean? Let's start. So, okay. So there are obviously two ways to do this, but again, what is the high level, intro to this, right? So this session assumes that you, at least so far, you have built a function or two. If you didn't, you might have a little bit of a difficulty understanding what's going on here, but that's still okay, to be honest. So a function, in the context of this session, think about a function as an API. Let's take it as simple as that. So, oops, I'm sorry. So once you start building, functions, and you keep building and building, what you end up having is a bunch of functions, right? It's kind of obvious, but when you have hundreds of functions, then what you see is that not all of your functions are actually exposing functionality to the outside world, but some of your functions are actually being used by your other functions. And some of your functions are actually handling some workflows. They're doing something, then they have to do something else. You figure out that your functions are actually turning into a big monolith, right? Doing a couple of different things that could have been separated into smaller pieces. And that separation could even be helpful to scale the functions themselves, right? So let me give you an example. When you're starting, when you're going to process an order, right? A shopping basket, you have a function that's going to process the shopping basket. You take the shopping basket, and then most probably you're going to need to do something per item in the shopping basket, right? You're going to change the inventory and so on and so forth, right? A lot of operations per item has to be calculated. Maybe you're gonna go and check inventory in a third-party system, reach out to another system, right? So there's a lot of work that needs to be handled per item, but on the high level, what your function is supposed to do is to process the shopping basket because it's processing an order, right? So in this case, you can definitely have a single function that does the whole thing from beginning to the end, but most probably you're going to have some difficulties, or it's going to get a little bit complex to scale out when you're going to process multiple items in the shopping basket, because then you have questions like, hey, am I going to do this sequentially, or am I going to do this in parallel, and how I'm going to do that? And don't get me wrong, there aren't solutions to these questions. There are solutions to these questions, and that's what the session is about. But long story short, this is one of the problems that we're going to talk about. Another problem is maybe, you have a very long process, and you don't want to have that, in a single function, but mostly have it, from one function to another, because one function is calling another, the other one is calling another, and then you have sequentially a chain of functions, essentially. That's another scenario that we're going to talk about. Another scenario is when a function has to wait for a third-party system, right? It does something and then has to wait for something to happen outside of your world of the function app, right? So those three scenarios, we will talk about these in detail. But my point is, once you have, once you're building more than one function, right, then you're getting into this world where you are a little bit worried about, hey, how I'm going to orchestrate those functions in terms of how do I manage how they talk to each other? How do they get things done in a cohesive manner? How do they work together, and how can I see that from a high level? How do I do the orchestration? Because having multiple functions, accomplishing a single job together, and especially when you have multiple, things to accomplish as part of a function solution or a function app, then that look gets more complex. Every time you add more functionality, you end up having hundreds of functions. Some of them talk to each other, some of them don't. You kind of lose track of which one is talking to which one, and so on and so forth. And when you introduce changes, you risk introducing breaking changes across your functions as well. And I am assuming you don't have, unit testing or integration testing. Those are definitely a separate discussion that we should take a look at. So long story short, what we have here is two solutions. The first one is the Azure Logic Apps. Azure Logic Apps helps you when you want to orchestrate your functions in a visual plane. So you want to see things, right? You want to have a diagram and be able to play with it, right? So this is especially very valuable if, you know, the workflow is going to be manipulated or edited or changed by someone who is maybe not a developer, right? And that happens. You know, you have business people in the process, and they would like to change the workflow, change some of the, you know, statements or conditions, how the business runs, that is reflected into your code, right? So the Logic app makes it really easy, and we will look into that. We're going to have a demo. The other benefit of Logic App is the concept of connectors. So Logic App has these connectors that can make it really easy to integrate with third-party systems, such as, you know, if you're gonna use some Twitter APIs, there's a Twitter connector. If you're gonna use some Office 365 APIs, if you wanna trigger a function when there's a new email in an inbox, so you can definitely build this thing from scratch. But then if you're using Logic Apps has a connector for Office 365, and there's tons of connectors in Logic Apps. So those connectors, it makes it really easy to get things out the door, to ship, you know, production stuff. I'm not gonna say it's as cheap as building it yourself in the short term, maybe, but at the end of the day, you know, whatever you build, a line of code that you write, this is a line of code that you have to worry about and you have to maintain on the long run as well. So sometimes it's better to offload it to someone else. And in this case, these connectors might be that leverage to push functionality out there without really worrying about, hey, are my integrations with these third parties through healthy and running, because someone else is providing those. So that's where Logic App shines. The other solution that we have is Azure Durable Functions. So Durable Functions is a way to build stateful functions. It helps you persist the state of a function, and then have multiple functions work together, because it is handling the state transition from one function to another for you. Okay, so it's a way to codify essentially the workflow into your C# code, right, or JavaScript code. So these are the two products. Durable Functions, I'm not sure if we should call that a product. It's essentially a library that you add into your Function app, and it's not a service. It's just a library that you add. It depends on a storage subsystem, obviously, that we will talk about. But other than that, it's not a hosted service like Logic Apps is. I have to sip through this because I have sore throat, and unfortunately, I waited for it to go away, but I will miss the deadline for this session. Cool. So what about durable functions? Let's talk about it a little bit. We did mention stateful functions, right? It manages the state, it checkpoints for us, and it restarts our functions when needed. And restarting means replaying back our function. I believe the best way to showcase this is actually to go and see it in action. And for that, I'm going to jump straight into, let me do this, our first problem. Yeah, problem one, function chaining. This is what we have already discussed. Like, you know, I have one function that goes and outputs something that another function has to take over and then process and continue, and then another function takes over, and so on and so forth. So again, this is pretty doable, right? You can have queues between every function, and you know, you can have a function listen to a queue, another one can put messages into a queue, and so on and so forth. But you are doing a lot of plumbing, right? First of all, you don't want to do that, obviously. And then one of the benefits of this concept is the fact that, you know, when a function does process a particular job, and the end result might be multiple jobs out of that. So think about the shopping cart, which is actually my next example. Let me jump into there to go a little bit faster. Fan in, fan out, right? Function one is outputting a lot of jobs as the result of whatever it does, right? Function 1 takes the shopping cart, it processes the shopping cart, it does some validations, checks, and so on and so forth. But then there's an additional, a job that has to be processed per item in the shopping cart. So the first message comes in, shopping basket processed, and then in the shopping basket there were 50 products. So I'm putting 50 messages into the next queue, and then someone else has to take has to take care of those 50 jobs in the queue. So what ideally you want to do is function 2 in this case, you want it to be able to fan out, kind of scale, and be able to process the 50 functions in parallel. One of the big problems with this one is, as you can tell, function 3 in this case, which is the consolidating function, should only run when all of the function 2 instances are completed. And this is not an easy implementation, let me tell you that, especially in a disconnected, distributed environment, right? You have 50 different functions, they're running probably on different servers and stuff, and you're going to run something else when all of them have succeeded, right? They have a result. So this requires a lot of checking and monitoring and so on and so forth. So again, a lot of plumbing in terms of getting this thing running. And all this plumbing can be handled by durable functions pretty easily. So let me show you how that's done. So what I'm going to do is to open up a brand new Visual Studio instance for you. And right now it's opening up on my other monitor. I'm going to bring it up. Come on. Oh, here we go. Okay, let's say continue without code. Here's what I'm going to do. File, new project. And we're going to select Azure Function. Come on. Okay, next. The name doesn't matter for now, but I'm going to put this somewhere else. Give me a second. Let me put it into a temporary directory. Function at 1 is good. I'm going to say next. An HTTP trigger, that's okay. We're going to go with .NET 6. That's okay. Authorization level, let's make it anonymous for now to make things easier. So I just wanted to take this from scratch so that you guys can see what's going on. So right now we got a function app with an HTTP API in it. And let me dismiss for now. What I'm going to do is I'm going to right click on that and say add new Azure function. I'm just trying to bring in the new template UI. So I'm like saying, hey, I'm going to add a new function into my project. I say add, and from here I'm going to scroll down and go and pick durable functions orchestration. So when I do this, this is going to spin out some default code that we will look into. So if we look in here, you're going to see that there's a couple of different concepts. The first one is the concept of an activity function. Activity functions are functions that do the actual work. And then we have the orchestrator function. You can see that the orchestrator function in this case is calling the activity function, right, 3 times sequentially. Every time it calls it, it is using this await keyword. And finally, it returns the output. So this is called the orchestrator. Okay, the orchestrator that orchestrates multiple functions, and this is the activity. And then this one is a simple HTTP trigger API that starts an orchestrator instance. So we give it a name, say, hey, this is our orchestrator. We want to start a new one, and then we are returning some response status because this is going to work asynchronously, right? We are getting the instance ID, but start new async means that the orchestrator will start, but we will not wait for it to finish. The output will be stored, and we will go and reach out to that with the instance ID if we want to. So obviously, because of the time constraints in this session, I have to keep things really simple. But what's really happening here is I have an orchestrator that is calling other functions, right, 3 times sequentially. These functions might be running on other servers. I mean, there's no way for us to know for sure because the underlying infrastructure scaling is being handled by the Azure Function Service, right? But we're passing 3 parameters and we're getting the results. The nice thing here is this function, when it comes to this, it's gonna call function hello with Tokyo and then go to sleep. So, and that's where the beauty of durable function comes in. Essentially, what's happening behind the scenes is that this is going to be snapshotted, okay, and there's going to be an history table capped. So this orchestrator will be taken into sleep until the activity function is completed. Once it's completed, it's going to restart, replay, but will not run this activity function again, but it will restore its result that it gets from in the initial execution. It will put it into the collection. Then it will run this function with the new parameter and then go to sleep again. So essentially, this orchestrator will run once, twice, 3 times, and then a 4th time when all of the activity functions have been called. And then we are done. The output will be, this is essentially the function chaining, right? You're calling 1, getting the result, calling 2. The only difference is that there's a high-level orchestrator that talks to every function and gets the result. And while it is waiting for the other function, it is not actively waiting, it's passively waiting. It's sleeping. So we are not paying for the amount of compute resources being used. When we jump into, let me go there. When we jump into this particular scenario, right, when we have, let me see, when we have the function chaining scenario, sorry, fan out, fan in scenario. So for that, I'm going to bring another piece of code in here. Let's go with this. Okay, I'm simply going to replace this. The only difference you're going to see here is that I'm not awaiting for every function one by one. I'm calling all of them, and I'm waiting all of them at once. And that's the only difference. So what's happening here is this orchestrator is running. This orchestrator is calling 3 instances of this function with different parameters, and it's waiting for all of them to complete. So the playback count for this function is much lower than the previous one because it's not a sequential call. So it runs once, it runs twice, and we are done. We're going to get all of the results from all of these functions. Okay, I could have 50, 60, 100, whatever. I could have this in a for loop, and the fan out would happen behind the scenes. And as you can tell, there's no plumbing in terms of, hey, let's manage queues, let's manage messages and stuff between those, and there's none of that. We are essentially using, in the case of C#, we are essentially using the task parallel library to manage these as tasks. But what's happening that every task is actually a call, an HTTP call, actually, not literally, but think about it as an HTTP call to another function being hosted somewhere else in the server farm. So that's kind of the durable function scenario. Shortly. Another use case that is really nice is this human interaction and the eternal process. You can have a function orchestrator sleep forever. There's an API for that, internal functions API, durable functions API for that. You can call that and say, hey, this function, I want it to wait for 20 minutes. It's going to wait passively, so you're not going to pay for it. And 20 minutes later, it's going to wake up again and do something. Another one is the external event. So you can open up a webhook and your function can wait without paying for the underlying infrastructure or anything because it's going to be in sleep, but it's going to have an event trigger that can be called by a third-party system. So all these scenarios, thanks to a durable function, gets really easy to implement. So, I mean, this slide deck is going to be online, so you can definitely go in and read those in details. There are a couple of things that are kind of important when you are building orchestration with the durable functions. You have to be careful about some of the tips and tricks to ensure that you're using, you're getting the most out of the platform. So that's what this slide is about. We're not going to go into it right now. So the durable task framework has a couple of storage engines that it requires to store the snapshots and the history. So there are a couple of options on there. Azure Storage is the default, but you can go and use something outside Azure as well. So we did discuss a little bit about logic apps, so I want to jump straight into a demo and show you how the same thing could have been done in logic apps, right? So for that, I am gonna bring this one. So this is a logic app This is a very, very simple one. The purpose is to show you how a logic app could orchestrate a function, right? So I'm going to say edit. This function app is already built. So it has an HTTP endpoint where we can give a list of image links in an array. So we have a Azure function that we're going to use for this. The Azure function is able to detect food in an image. It only gets one URL of an image and is able to tell us back if there's a food in it or not. So it does the core processing. But what we want to have is the ability to have a list of images and then return back only the images that have food in it. So that's what we want to have. So in this case, we are getting a list of items in an array, and then we are initializing a variable called food images. And you can tell how simple things are in logic apps by how we are defining a variable, right? It's a simple box that we drag and drop. And then we have a for each loop that iterates through the array, and for every item it calls the food detector Azure function. And then we have a condition. We say, hey, if the result of the Azure function is HTTP 200, it looks like it's how it's built, then there's food in it, and put that into the array that we created. If there isn't food in it, we don't have to do anything. And finally, we are serializing back our array with the food images in it and be done with it. So obviously, this can be built in durable functions as well. But as you can tell, the flow, the decisions, sorry about that. So the flow, the decisions are visually, very easy to understand. And these are things that I can change without writing code and deploying and so on and so forth. And this one has only a single Azure function, but you can imagine having multiple Azure functions working together and the relationship between those being built in design mode in a logic app. And on top of that, again, this example isn't using it, but there's the concept of connectors that you can use as part of the logic apps. And that's where the power of logic apps comes in, the connectors and the visual aspect of being able to design the workflow. So with that, that's pretty much all I wanted to cover in this session. 2 different ways to orchestrate functions. Here are a couple of links I wanted to share if you're interested and want to go a little bit deeper. Here is where you can download this slide deck, and my Twitter alias is out there as well. In case you have any questions, please feel free to reach out to me on Twitter, and you can reach out to me on LinkedIn as well. Yeah, hopefully this is helpful. Enjoy the rest of the conference.